Hi grade 8s, welcome back to another one of our video lessons. So today we're going to continue on page 128. In the previous lesson we looked at solving problems that involve triangles and quadrilaterals, and then I asked you to look at exercise 11.7 and do questions 1, 2, 3 and 4. Alright guys, so today with you I'm going to do number 5 because we haven't really dealt with circles much yet, so I'll work through number 5. And then you guys are going to do 6, 7, and 8 for homework. Alright. And then we'll continue with the next section. Alright, so let's look at number 5. So it says, F and O are the centers of the smaller and larger circles respectively. Okay guys, please open your textbooks on page 128. I want you to look at the diagram. I have the diagram on the board behind me, but I also want you to have your textbook open so that you can do this with me and not just listen to me do it on the board. Right, so F and O are the centers of the smaller and larger circles respectively. The circles intersect each other at G and K. Okay, so G and K, that's where the two circles intersect each other. FO produced meets the larger circle at H. Okay, so FO is the line between the two centers, and if we extend it, it goes to H, and this distance over here is your diameter of the biggest circle, because it's going through the center. FG, FK, KH, GH, GO, and KO are drawn. Okay, so they're drew in those lines. KFH is 57 degrees and OKH is 16 degrees. Okay, great. Number 1, or rather A, complete the following statement. A kite is a quadrilateral width. Okay, guys, so here there's many, remember there were many classifications of a kite. There's many characteristics a kite can have. So you can complete that sentence with whichever one you want. So we could say that a kite is a quadrilateral with two pairs of adjacent sides equal. Okay. All right, so that's 5A. B, if FG equals to 3 units and GO equals to 4.75 units, determine the lengths of FK, KO, and OH. All right, so let's look on the diagram. So if FG is 3 units, okay, FG, this is 3 units. And they also tell us that GO is 4.75. Okay, GO is 4.75. Okay, what you should notice is that these two measurements that they gave us are the radii of each circle. So here we have the radius of 3, and here we have the radius of 4.75. Now remember, radius in a circle is always the same. Doesn't matter from where you go from center to which point on the circumference. So if GO is 4.75, it must mean that OK is also 4.75, and the same as OH, which is also 4.75. The same thing will go with F. If FG is 3, then FK is also going to be 3. All right, so let's see if they actually want us to find any of those. So number 1, FK. Here it is. So what are we going to say? We're going to say FK equals to 3. What is our reason for saying that? Okay, the reason for stating this is that while we're using the radii of the circle center F, okay, so we can say that FK equals to 3 radii of circle center F. Okay. Sorry about that. It almost disappeared, my sneeze. All right, so that was the first one, FK. The next one we need is KO. All right, KO is over there, so we're going to say KO equals to 4.75 reason radii. Okay, I don't have space there to fill it in, but you're just going to say radii of circle center O instead of F, so I know which circle I'm talking about. All right, so that's that, and then the next one is OH. Okay, so OH is this distance over here. Exactly the same reason. We're going to say OH equals 4.75 and exactly the same reason as for KO, because they are all radii of center circle O. All right, so that was number B. Let's look at C. Identify 3 kites and state which one is an arrowhead kite. All right, guys, so we haven't really talked about an arrowhead kite, but basically it's a four-sided figure that fits the same criteria as a kite. So we have 2 sides that are long like that. And instead of having our normal kite that does that, we're going to put these pieces on the inside like that. Okay. So we still have 2 pairs of adjacent sides equal. It's just that the kite is now folded inwards. Okay. And this is known as an arrowhead kite. All right, well, let's first identify 3 kites and which one is an arrowhead. Okay, well, remember, for a kite to be a kite, we need to have 2 pairs of adjacent sides equal. All right, so let's first look at the first kite. So we have OGFK. Okay, there's the figure OGFK. Is it a kite? Yes, because this side is the same as that side, and this side is the same as that side. So it fits our criteria of a kite. Right, so let's write these kites down. So we have OGFK. Right. Then what we can do is we can look at the same FGK, but instead of O, we're going to make it H. Okay. So now we need to again check whether it's the same, same size sides. Okay. So first one, FG is the same as FK. So that criteria is met. What about these lines over here? Okay, are they the same? Well, let's think about it, right? We haven't done congruency, or have we? I think, yes, we have done congruency. So we know that we know how the triangles are the same. We need to match up the sides. We don't have the congruency conditions yet. That's fine. All right, so how are we going to prove that this is the same side? Okay, because remember, it's not a radius and it's not a diameter. Okay, well, let's look at these 2 triangles. Are these the same triangles? Even these 2 big triangles, okay? So we have a common side here, which is the same. We have this side, which is the same. We have that side, which is exactly the same. And we just need to show that this side and that side is the same. Well, how can we show that? Let's think. They are equal. I'm just trying to figure it out how we're going to prove that they are equal. Okay, guys, let's carry on. So I stated this thing for a bit, trying to figure out how to prove this. And yes, we can prove it, but we just haven't covered that stuff in geometry yet. So I think for this question, they didn't want us to prove that it is a kite. They just wanted us to identify it, okay? We can prove that this side is the same as that side by going through the angles and working through this sum from left to right. But we're not going to do that yet because we haven't gotten there yet, okay? So what I think they just wanted us to is identify. So it will be, instead of O, it will be H, G, F, K, okay? Right, and then the third kite that we have is the arrowhead kite over here. Okay, so that's the same as that, that's the same as that. Therefore, it meets our criteria. So that is going to be H, G, O, K. And this one is the arrowhead kite. Okay. All right, so let's continue. So identify 3 kites. D, name 3 pairs of congruent triangles. Okay, so we need 3 pairs of congruent triangles. Okay, well, remember, the kites are symmetrical. They have one line of symmetry. So if we have a kite that looks like that, we can always slice it down the middle and it will be exactly symmetrical. That is one of the properties of a kite. So if they want us to find 3 pairs of symmetrical triangles, we literally have to just go to these 3 kites that we have and slice them in half. So we have the first kite that's there. if we now slice it down the middle, it will give us two congruent triangles. So OGF and OKF. If we take the next kite, which is this bigger one over here, slice it in half again, we'll get FGH and HKF. And we can also slice our arrowhead in half, so it will be HOG and HKO. Okay, those are the three pairs of congruent triangles. All right, guys, so remember our congruency sign. The way I wanted you to do this is as follows. So if we talk about the first one, we're going to say triangle HGF is congruent to triangle HKF. And I want you to show me that for the other two triangles as well, two pairs of triangles. All right, let's look at 5E. Calculate the values of X, Y, and Z. Give reasons for your answers. Okay, so let's do that. Okay, I'm going to rub this off. Okay, so they want us to find angles X, Y, and X, Y, and Z. Where's Z? I don't see Z. Let me just quickly check. Oh, Z is over there. This is Z. All right, cool. So let's start. Let's try to figure this out. Okay, let's use the information that we have. Right, so this here is 57 degrees, and this is also 57 degrees. Why is it 57? Because we have congruent triangles. Okay. Right, so does that help us? Not really. Okay, we have sides. This is 3 and that's 3. We also have another side, which is 4.75. All right, well, we don't really know if we have a 90-degree angle, so we can't really assume to try to work out this third side. Okay, let's keep thinking. Okay, so all right, let's continue. Okay, so the trick here is the radii. Okay, because if we have radii coming from the center of the circle to the edges of the circle, we have essentially isosceles triangles. And if we have isosceles triangles, remember the angles are the same as the sides. Okay, so the trick to this whole question is this 16 degrees. Okay, if we look over here, we have a center circle there. So this OH is the same size as OK, which is 4.75. Okay, if these sides are the same, it must mean that these angles are the same. All right, so we're going to start with that. Remember, we need to show all the reasons and all of our calculations through this. Okay, so let's go through it. So let's first say that OH equals to OK. What is the reason? It's radii. Okay. Then we're going to say that X equals to 16 degrees. What is our reason? Isos triangle. Which triangle? OKH. Okay. So now we found that X is actually 16 degrees as well. Okay. Now from there, we can move on to get Y, because here we have angles on a straight line. So we have Y plus this angle equals to 180. While we have 16 and 16, so we can definitely work out that angle in between. Okay, so KOH equals to what? It equals to 180 minus 16 and 16 is 32, which equals to 148 degrees. What is our reason for stating that? It is angles of triangle, or sum of angles of triangle. Right, so we got that to be 148 degrees. Now we can get y. Y equals 180 minus 148 degrees, which equals to 32 degrees. Okay. What is the reason for this? Well, it's angles on straight line. Okay. Right, we also could have used that the two interior angles is the same as the exterior angle of a triangle. So y equals to 32, but we'll cover that in the next few lessons. All right, so we've got our y. Once we have our y, we can fill this in. This is going to be 32 degrees. Okay. Now we can get z because z is in this triangle, which is 180 degrees. We have 57, we have 32. Therefore, z equals to 180 minus 32 degrees minus 57 degrees, which is going to give us, that's 80, that's 89. So we take 89, so this is going to be 91 degrees. Okay, so Z is 91 degrees. Okay. All right, guys, so that's how we find these angles, and you have to give me the accompanying reasons. Please, guys, don't just give me answers. They need to follow with reasons. Right, let's look at the last part, 5F. Determine the size of KOH. Give reasons for your answer. Okay, let's look. KOH. Well, we already have it. We worked it out. It's 148 degrees. And we got that from figuring out that it's an isosceles triangle. So we could say, so guys, when you are faced with a situation where they are asking you for something that you've already shown and you've already proved, you don't have to redo all that work just so that it's there in the question. You can tell me in the question, you can say that the answer is this, I've proved it in 3.1. Okay, refer to 3.1 for the proof. Okay, so I don't want you to do double work or waste your time in a test scenario if that's what happens, because sometimes they'll ask part one, but you'll go through the whole lot to answer it, or you won't see the shortcut to answer it. And then they'll ask something again that you've already done. Okay, so to avoid that, just tell me where you've done it. Okay, so like for this question, I'm going to say KOH equals to 148 degrees. The reason for this, I'm going to say, shown in, where did we show this? So, well, we worked this out when we were doing E. So we can say that proved in 5E. Okay, and that's fine because then I'll look there, I'll see your proof, and I'll give you the marks. All right, guys, so these geometry questions are complicated, they are long, and you do have to stare at them for a while to try to figure out where is that one little catch where you pull on the string and it starts unraveling. Guys, geometry questions are exactly like that. You'll look at it and you'll say, I don't know what to do. But there'll be one piece of information that will work with another piece, and then you can get an equation solved for one thing. Then using that, you can get the next thing. Using that, you can get the next thing and finally get to the thing that you actually need to answer. Okay. All right, guys. So what I want you to do is carry on working through this exercise. So for the homework for this lesson is going to be to do questions 6, 7, and 8. Okay. Then what you can do is look at the revision exercise. So get it done by the end of this week. And in the next lesson, we're going to start with topic 12, which is geometry of straight lines. Okay, cool, guys. I hope you enjoyed it, and I'll see you in the next lesson.